Quality expert W. Edwards Deming used 14 points to indicate how he implemented TQM. We developed these into 7 concepts for an effective TQM program. 1. Continuous improvement. 2. Six Sigma. 3. Employee empowerment. 4. Benchmarking. 5. Just-in-time, JIT. 6. Taguchi concepts. And 7. Knowledge of TQM tools. TQM requires a never-ending process of continuous improvement that covers people, equipment, suppliers, materials, and procedures. The basis of the philosophy is that every aspect of an operation can be improved. The end goal is perfection, which is never achieved but always sought. Plan Do Check Act. Walter Shewhart, another pioneer in quality management, developed a circular model known as PDCA, Plan, Do, Check, Act, as his version of continuous improvement. Deming later took this concept to Japan during his work there after World War II. The PDCA cycle, also called a Deming circle or a Shewhart circle, is shown in Figure 6.3 as a circle to stress the continuous nature of the improvement process. The Japanese use the word Kaizen to describe this ongoing process of unending improvement, the setting and achieving of ever higher goals. In the US, TQM and zero defects are also used to describe continuous improvement efforts. But whether it's PDCA, Kaizen, TQM, or zero defects, the operations manager is a key player in building a work culture that endorses continuous improvement.
The term Six Sigma, popularized by Motorola, Honeywell, and General Electric, GE, has 2 meanings in TQM. In a statistical sense, it describes a process, product, or service with an extremely high capability, 99.99997% accuracy. For example, if 1 million passengers pass through the St. Louis airport with checked baggage each month, a Six Sigma program for baggage handling will result in only 3.4 passengers with misplaced luggage. The second TQM definition of Six Sigma is a program designed to reduce defects to help lower costs, save time, and improve customer satisfaction. Six Sigma is a comprehensive system, a strategy, a discipline, and a set of tools for achieving and sustaining business success. The more common Three Sigma program would result in 2,700 passengers with misplaced bags every month, while a Six Sigma program for baggage handling will result in only 3.4 passengers with misplaced luggage in 1 million air passengers observed.
The term Six Sigma was popularized by Motorola, Honeywell, and General Electric, GE. It is a strategy because it focuses on total customer satisfaction. It is a discipline because it follows the formal Six Sigma improvement model known as DMAIC. It is a set of 7 tools that we introduce shortly in this chapter: check sheets, scatter diagrams, cause and effect diagrams, Pareto charts, flow charts, histograms, and statistical process control. The formal Six Sigma improvement model known as DMAIC. This 5-step process improvement model: 1. Defines the project's purpose, scope, and outputs and then identifies the required process information, keeping in mind the customer's definition of quality. 2. Measures the process and collects data. 3. Analyzes the data, ensuring repeatability. The results can be duplicated, and reproducibility. Others get the same result. 4. Improves by modifying or redesigning existing processes and procedures. And 5. Controls the new process to make sure performance levels are maintained. Implementing Six Sigma is a big commitment. Indeed, successful Six Sigma programs in every firm, from GE to Motorola to DuPont to Texas Instruments, require a major time commitment, especially from top management. These leaders have to formulate the plan, communicate their buy-in and the firm's objectives, and take a visible role in setting the example for others. Successful Six Sigma projects are clearly related to the strategic direction of a company. It is a management-directed, team-based, and expert-led approach. Employee empowerment means involving employees in every step of the production process. Consistently, research suggests that some 85% of quality problems have to do with materials and processes, not with employee performance. Therefore, the task is to design equipment and processes that produce the desired quality. Techniques for building employee empowerment include 1. Building communication networks that include employees. 2. Developing open, supportive supervisors. 3. Moving responsibility from both managers and staff to production employees. 4. Building high morale organizations. And 5. Creating such formal organization structures as teams and quality circles. Teams can be built to address a variety of issues. One popular focus of teams is quality. Such teams are often known as quality circles. A quality circle is a group of employees who meet regularly to solve work-related problems. The members receive training in group planning, problem solving, and statistical quality control. They generally meet once a week, usually after work but sometimes on company time. Although the members are not rewarded financially, they do receive recognition from the firm. A specially trained team member, called the facilitator, usually helps train the members and keeps the meetings running smoothly. Teams with a quality focus have proven to be a cost-effective way to increase productivity as well as quality. Benchmarking involves selecting a demonstrated standard of products, services, costs, or practices that represent the very best performance for processes or activities very similar to your own. The idea is to develop a target at which to shoot and then to develop a standard or benchmark against which to compare your performance. The steps for developing benchmarks are: 1. Determine what to benchmark. 2. Form a benchmark team. 3. Identify benchmarking partners. 4. Collect and analyze benchmarking information. 5. Take action to match or exceed the benchmark. Benchmarks often take the form of best practices found in other firms or in other divisions. Table 6.3 illustrates best practices for resolving customer complaints. When an organization is large enough to have many divisions or business units, a natural approach is the internal benchmark. Data are usually much more accessible than from outside firms. Typically, one internal unit has superior performance worth learning from. Benchmarks can and should be established in a variety of areas. Total quality management requires no less. The philosophy behind just-in-time, JIT, is one of continuous improvement and enforced problem solving. JIT systems are designed to produce or deliver goods just as they are needed. JIT is related to quality in three ways. JIT cuts the cost of quality. This occurs because scrap, rework, inventory investment, and damage costs are directly related to inventory on hand. Because there is less inventory on hand with JIT, costs are lower. In addition, inventory hides bad quality, whereas JIT immediately exposes bad quality. JIT improves quality. As JIT shrinks lead time, it keeps evidence of errors fresh and limits the number of potential sources of error. JIT creates, in effect, an early warning system for quality problems, both within the firm and with vendors. Better quality means less inventory and a better, easier to employ JIT system. Often the purpose of keeping inventory is to protect against poor production performance resulting from unreliable quality. If consistent quality exists, JIT allows firms to reduce all the costs associated with inventory. Most quality problems are the result of poor product and process design. Genichi Taguchi has provided us with three concepts aimed at improving both product and process quality: quality robustness, target-oriented quality, and the quality loss function. Quality robust products are products that can be produced uniformly and consistently in adverse manufacturing and environmental conditions. Taguchi's idea is to remove the effects of adverse conditions instead of removing the causes. Taguchi suggests that removing the effects is often cheaper than removing the causes and more effective in producing a robust product. In this way, small variations in materials and process do not destroy product quality. Taguchi introduced the concept of target-oriented quality as a philosophy of continuous improvement to bring the product exactly on target. As a measure, Taguchi's quality loss function, QLF, attempts to estimate the cost of deviating from the target value. Even though the item is produced within specification limits, the variation in quality can be expected to increase costs as the item output moves away from its target value. These quality-related costs are estimates of the average cost over many such units produced. The Japanese factory strove to produce as many components as close to the actual target as possible. See Figure 6.5a. The QLF is an excellent way to estimate quality costs of different processes. A process that produces closer to the actual target value may be more expensive, but it may yield a more valuable product. The QLF is the tool that helps the manager determine if this added cost is worthwhile. The QLF takes the general form of a simple quadratic equation. See Figure 6.5b. To empower employees and implement TQM as a continuing effort, everyone in the organization must be trained in the techniques of TQM. In the following section, we focus on some of the diverse and expanding tools that are used in the TQM crusade. Tools for generating ideas. Check sheet, an organized method of recording data. Scatter diagram, a graph of the value of one variable versus another variable. Cause-and-effect diagram, a tool that identifies process elements, causes, that may affect an outcome. Tools for organizing the data. Pareto chart, a graph that identifies and plots problems or defects in descending order of frequency. Flowchart, process diagram, a chart that describes the steps in a process. Tools for identifying problems. Histogram, a distribution that shows the frequency of occurrences of a variable. Statistical process control chart, a chart with time on the horizontal axis for plotting values of a statistic. To be continued.